of all is, what is electric charge? See, charge is the cause of current or charge is the source of current, I must say. So electric charge is a basic property of a matter. It is the basic property of matter, similar to mass and length. See, every object or every matter around us, you know, every matter around us is made up of atoms. You all must have read this in chemistry. Atom means we have a nucleus at the center, it has proton in it, and electrons are around it. So guys, basically proton is having some mass, electron is having some mass, and as a result nucleus is having some mass. So at every body is made up of atoms, so we can say that every body must be having some mass, right? Also the protons and the electrons are having some charge. That means every body is made up of certain amount of charge depending on the number of electrons and protons it is having. So charge is a fundamental property. Fundamental means it is related to the basic level. It is the fundamental. Every body must be having some, this is made up of atom, so it is a combination of these electrons and proton. So it is a fundamental property like mass and length. It also determines the nature and the magnitude of the force between two charges. Now what is the meaning of this statement? Suppose the charges on two bodies are positive, so obviously the force will be repulsive, they will repel each other. But if this is positive, this is negative, we know that opposite charges attract. So the type of charge determines the type of force. The type of charge between the bodies determines the type of force, whether the force is repulsive or attractive between the charges. Now what is the SI unit of charge? It is coulomb. SI unit of charge is coulomb. For example, I say the charge on body is 2 coulomb or minus 3 coulomb, plus 2 coulomb positive 2 coulomb charge, minus 3 means negative of 3 coulomb charge. So coulomb is the SI unit for charge. So it is a fundamental property. Now guys, you know that in any material, not all electron, in conductors especially, not all electrons are bounded to the atom. We have certain free electrons. Free means that are not bounded to the nucleus. Now guys, what will happen? These electrons will make the current in the circuit. When these electrons will flow, we have a current in the circuit. So basically this charge, the flow of charge is the cause of electric current in any circuit. So what are the various properties of electric charge? Let's have a look at this also. So first is the magnitude of electric charge is independent of the type of force. What is the meaning of this statement? It means the magnitude of the charge is independent of the type of the magnitude of the charge is independent of the type of charge. That means we can have plus 2 coulomb charge, we can have minus 2 coulomb charge. So basically you can say the magnitude is 2 coulomb, but one is positive, other is negative. So the magnitude is independent of the charge. The magnitude does not determine the type of charge. This is the first point. Next is similar charges tend to repel, like positive, positive, negative, negative, but opposite charges tend to attract, like positive, negative, right? Next is electric charge is a scalar quantity. Now guys, what is the meaning by this? What is a scalar quantity? Scalar means only magnitude is there. Scalar means only magnitude, no direction is there. Also, one meaning of scalar is also this, like suppose if I have a body A having 2 coulomb of charge, right? If I have another body B having 3 coulomb of charge, if I combine these two bodies to make a single body C, the charge on C will be 2 plus 3, which is 5 coulomb. So you can see the charge is scalar. You have directly added them. It's not like the displacement. It's not like displacement, like when you calculate the resultant in case of vector quantity, you have to use vector rules. But charge is scalar quantity, like distance. 2 meter plus 10 meter, 12 meter, like distance charge. We can directly add the charge because it's a scalar quantity. Clear? So we can combine the charge and just add them with sign. You have to add them, add with sign. It's a scalar quantity, right? It does not have any direction. It is just having some amount of magnitude. Okay, charges are additive in nature, as I have said. Just add the charges with sign, right? Next is charge is a conserved quantity. Guys, conservation of mass you have read. Mass is neither created nor destroyed. Like energy, energy can neither be created nor be destroyed. Similarly, charge is also conserved. You can see if I have combined two charges, 2 and 3 coulomb, the resultant is 5 coulomb. So charge is conserved na? initial charge is equals to final charge. So conservation means initial charge is equals to final charge. Like initial mass equals to final mass, we have initial charge equal to the final charge, guys. Initial charge equal to the final charge. Charge is quantized. Charge is quantized. Now what is the meaning of this? Important. This is very, very important, guys. Now listen to me very, very carefully. Charge is quantized. What is the meaning of this? See, basically one electron is having a charge of 1.6, negative of 1.6 into 10 ki power minus 19 coulomb, right guys? So guys, if a certain body is having 2 extra electrons, that body will be having of how much charge? 2 into 1.6 into 10 ki power minus 19 coulomb. If a body is having 5 electrons, extra electrons, the body will be having how much of charge? How much of negative charge? Minus 5 into 10 ki power minus 5 into 1.6. 5 into 1.6 into 10 raised to the power minus 19 coulomb. So guys, similarly 10 electrons, 20 electrons. So you can see the amount of charge is multiple of something. Multiple of this 1.6 into 10 ki power into 10 raised to 1 minus 19. The amount of charge on any body is multiple of E, where E is this charge on single electron. So guys, from here we can write Q is equals to NE, where N is 0, 1, 2, 3 and so on. It's an integer, you know, you can it's a whole number basically, right? It cannot be negative, it cannot be in fraction. So it means the charge is quantized. Quantized means we have certain value, we only can have certain value of charges. It's not like you can say the charge on a body is E by 2. It is not possible. Not possible. Charge on any body cannot be in fraction of E. If I say charge is 3E by 2, also not possible. Charge is quantized. It can only have certain values. Okay. So this is the meaning of quantized. Are you getting it now? So this means electric charge comes in discrete amounts. Discrete amount is n equals to 1, 2, 3. And there is the smallest possible amount of charge that an object can have. And that charge is equals to E. The least possible value of n. If a body is having certain charge is n, 1. For n equals to 0, the charge would be 0. But the least amount of charge a body can have is E. That is the charge on single electron. So guys, these are the various properties related to the charges. Clear? Okay. Now keeping this thing in mind, we will be having a discussion on electric field and electric potential. See guys, basically what is electric potential? It is a potential at a point in an electric field is defined as the work done in moving a unit positive charge from infinity to that point without acceleration or without any change in its kinetic energy. Now seems difficult to understand. Let me explain you that. See, suppose guys, I have a positive charge. Now basically if I want to bring certain positive charge, basically suppose I have a source charge. This is the source charge. And I want to bring this positive charge nearer to this charge. Okay. This will repel. This charges will repel. So obviously I have to apply some work. I have to do some work against the force to bring this charge nearer to this charge. So guys, here work to be done. Certain work has to be done, right? So guys, what is the reason for this? See, suppose if I take any positive charge and I want this charge to go from A point to B point. So will it flow by its own? No, it won't flow by its own. Like if I tell you, suppose very basic example, you must have seen this in most of the cases. If I take 2 tankers connected and the water level in 2 tankers is same, will the water flow from here to here? No, it won't flow. But if I take the amount of water in 2 tankers to be different, like water in this tanker is up to this level, and water in this tanker is this level. So guys, now the water will flow from where to where? It will flow from here to here. Why? Because there is a difference of a thing known as pressure difference. Here we have more pressure. Here we have more pressure. Here we have less pressure, guys. So that's why water is flowing from high pressure to low pressure. So there is a gradient of something. There is something that is pushing the water to go from here to here. So some external push is required. There is a difference of a pressure. Similarly, guys, if you want charge to go from A to B, there has to be a difference of a certain parameter known as electric potential. It's like a pressure in here. It's like we have a pressure here. We have a electric potential here. We have a electric potential. So potential at A is VA, potential at VB is VB. So guys, in any conductor, if there is a certain amount of, there is a flow of certain amount of current, that means we have a potential difference, right? We have a potential difference. So guys, now let's say, considering the same case, if I want to bring another positive charge Q, let's say this is Q and this is Q naught. Q naught is a charge and Q is a source charge. I want to bring this Q naught from B to A. So guys, some external work has to be done because the charges will repel. I have to apply some external force. So guys, work done, or I must say energy spent in moving this charge from here to here is what? Is nothing but Q into potential difference, VA minus VB. Q naught into VA minus VB. So work done due to the potential difference is there. If there is no potential difference, no work will be done. If there is no potential difference, no work will be done. Okay, so this is the case. So work done in moving a charge from one point to another is Q naught VA minus VB, where VA is the potential at A, VB is the potential at B. So just it is similar to the pressure in this case. Clear, guys? Now let's say if I am bringing this charge B from infinity, so what will happen, guys? At infinity, the electric potential is considered to be 0. At infinity, the charge is brought from infinity, that is at a very, very larger distance, right, guys? So what will be the work done? It will be Q naught into VA. So what is VA, guys? It will be work upon Q naught. If Q naught is 1 coulomb, VA will be equal to W, isn't it? If Q naught is 1 coulomb, we call it unit charge. So what is the definition of electric potential? The amount of work done in moving 1 coulomb of charge from infinity to that point is the potential at this point. What is the potential at A? The work done in bringing this charge from infinity to A, right? And the charge of the magnitude of charge is 1 coulomb. So this is the definition of electric potential, the work done, the work that has to be done. So this is what is written here. The electric potential in electric field is defined as the amount of work done in moving unit positive charge, 1 coulomb of charge, from infinity to that point. Infinity to that point without acceleration means we are bringing the charge very, very slowly, very, very slowly, or without any change in its kinetic energy. If acceleration is no change in acceleration means no change in kinetic energy. Clear, guys? So this is the electric potential. And what about potential difference between 2 points? Is the work done in the potential difference will be what, guys? W by Q from this. Potential difference is what? It is W by Q from this equation. Potential difference will be what? W upon Q. Simple. W upon Q. Work done upon divided by the charge. Clear, guys? So this is the case. Now what is 1 volt? Guys, W is equals to Q into V, right? So if W is 1 joule, charge is 1 coulomb, voltage would be 1 volt. Voltage is measured in volts, so it is 1 volt. So what is the definition of 1 volt? Is it the potential difference between 2 points of 2 points, if it should be if potential difference between 2 points, if right, if 1 joule of work is done, if 1 joule of work is done to move a charge of 1 coulomb between 2 points, if you have to do 1 joule of work, right, to move a 1 coulomb of charge from one point to another, the potential difference between those points is said to be 1 volt. This is the definition, and it comes in exam, directly comes in exam. Define 1 volt. Just write down this definition. Right, this is the definition of 1 volt. Clear, guys? So just remember this formula. It is very useful. This one, just remember this formula. Work done is nothing but Q naught charge into potential difference. Now if I ask you what is the cause of potential difference, right, I have told you that there is a positive charge, right, and there is another positive charge. If I want to move this charge from A to B or from B to A, there is potential difference. I have told you this. But guys, what is the cause of this potential difference? See, this charge will experience some force due to this charge, because this charge has a certain region around this charge. This charge has a certain region around this, under which this charge can experience some force. Like if I have suppose I am a positive charge and I have a certain region around me. So if any other charge comes in that region, that charge will experience some force. So that region is said to be electric field. That region is said to be electric field, guys. Electric field. I have a field around me, and that is electric. It's because it's a charge. So every charge has a certain region around it. These lines represents the electric field. So every charge has a certain region around it, whether it is positive or negative. In that region, another charge can experience some force, right? Similarly, for negative charge, we have electric field like this, right? For another charge, we have electric field like this. So if I bring any positive charge, it will experience some attractive force in this region only, right? That's why it's called field, right? Field. Clear? So what is electric field, guys? Can you read the definition now? It is a space around the charge where electrostatic means, guys, electric force. Electrostatic means electric force. Don't get confused by this word. It is electric force. That means force due to charges that can be experienced by another charge. Obviously a charge will experience force due to another charge only, right? Both bodies should be having some charge. Clear? So guys, this space around this is called electric field. Okay, and electric field is the cause of potential difference, right? We have a potential difference because there is electric field. It's as simple as that. And when you place a charge, it will move. Okay, is it clear, guys? So what is the cause of flow of charge? It is electric potential. And where does the electric potential come from? Due to the electric field, right? And who provides the electric field? I will tell you, don't worry about that. So question is, we have a question, how much work is done in moving a charge of 5 coulomb across 2 points having a potential difference of 12 volts? That, guys, the points is having a potential difference of how much? 12 volts. So what will be the work done, guys? Work done will be charge into potential difference, VA minus VB, Q into VA minus VB. It is 5, and what is potential difference? It is 12. So work done will be 60 joules. Simple. VA minus VB is given. Potential difference is given. Right? So this is how we calculate the work done. Is it clear? Okay. Now, let's start with the electric current. So I had told you, whenever there is a flow of charge, there is electric current. Why does the charge flow? Due to potential difference. What is the cause of potential difference? Electric field. So it is what is electric charge? The amount of electric charge flowing through a conductor in 1 second. How much charge is flowing in 1 second, guys? 1 second. 5 coulomb, 10 coulomb, 3 coulomb, whatever it is, that amount of charge is equals to the electric current, right? The amount of charge is equals to the electric current. So let's say in journal, if Q is the charge flowing in time t, Q charge flowing in time t, guys, that means what is current? it will be Q is equals to I into T. So from here guys, what is current? It is charge upon time. So if time is 1 second, it will be I is nothing but Q. So current is the amount of charge if time is 1 second. Simple. If time is 1 second. Clear? If time is 1 second. So amount of charge flowing in 1 second, that is equals to current, nothing else. So what can you relate? The current I is equals to charge upon time. Guys, remember this equation, it will be used almost in every question. Q is equals to IT. Charge, current, time. Coulomb, charge, this current is in ampere. The current is measured in ampere. Coulomb, ampere, and time in seconds. Clear? So what is the other unit of charge? You can see Coulomb per second guys from here. Charge in Coulomb, time in seconds. So it's in Coulomb per second. And Coulomb per second is nothing but ampere. Coulomb per second is nothing but ampere. It's written here already. Okay. So Q is equals to IT. Just keep on writing it down. Just pause the video and just keep on writing this down. Okay. Electric current Q is equals to IT. Let's try a question on this now. A current of 0.5 ampere is drawn by a filament of an electric bulb for 5 minutes. So guys, current I is 5 ampere. What is the amount of charge you have to calculate, and how much is the time taken? 5 minutes. Guys, convert this in seconds. So it will be 5 into 60, which is 300 seconds. So what is charge guys? Can you calculate the charge? Q is equals to nothing but Q equals to IT. So 5 into 300. 5 into 300. Okay guys. 5 into 300. So 1500 Coulomb. This is the amount of charge. Number of electrons also. Guys, you have to calculate number of electrons also. So what is Q? Q is equals to NE. What is N guys? It is nothing but 1500, which is Q upon E. What was the value of E? I have told you 1.6 into 10 raised to the power minus 19 Coulomb. So guys, this would be how much? 15 upon 16 into 10 raised to the power how much? 2 plus this is 2 and point decimal, this is minus 20. Right? So this would be 20. So it will be 15 upon 16 into 10 raised to the power 22 electrons. Calculate in fraction. So this is the number of electron. You can do it by your own, right? So it will be 10 raised to minus 20 plus 2, 22. So these are the number of electrons. Just if you want to calculate number of electrons, just use Q is equals to N into E. Clear? Are you getting this answer? Yes, everybody. Right? Q equals to NE and Q equals to IT. These are the two formulas you should be knowing. Q equals to NE and Q equals to IT. Clear? Should I move forward now? Okay. Now, see, we have read about the electric current, electric charge, potential difference, electric field. But if I ask you to draw the circuit, see, current flows in a circuit. Obviously, we have a wire, we have a bulb, we have a switch, we have many elements. We have to measure the current, we have to measure the voltage, we have a resistance also. So guys, we have certain electric symbols. If I ask you, right, if I ask you to draw the circuit diagram on a notebook, then you have certain symbols for certain elements, like for electric cell. So guys, I had told you I had asked you what was the cause of electric field. So guys, the cause of electric field is cell. Basically, cell provides the potential difference. Obviously, you won't get any current if you don't put the battery in the circuit. Why? Because battery creates the potential difference. Battery creates the potential difference, and it is denoted by this. We have two terminals. One is bigger than another. The bigger one is positive, and the shorter one is this negative. Battery is also denoted. See, it's a cell. Battery is nothing but combination of cells. So we have more than one cell. It's called the battery. Then we have resistor. I will tell you what is resistance. Then we have electric bulb. This is electric bulb guys, right? And this is variable resistance. Variable resistance means it can have more than one values of resistance. That is variable resistance or rheostat. Then we have a switch. It is open and this is closed. Like when we on the switch, it is this, and when we off the switch, it is this. Okay. Ammeter, it is used to measure current, A plus minus terminals. Voltmeter, this is voltmeter V, it is used to measure voltage. You will get these in the coming coming slides. A wire joint, when we cross that, when two wire are crossed, we have a joint, it is denoted by this. But if we don't have a joint, it is like this, it has crossed the wire. Then we have a fuse. Why fuse is used, I will tell you, right? But this is a symbol, circuit symbol for fuse. Now what is electric circuit? As I have told you, it is an electrical path, guys. Electrical path means it consists of electric current consisting of wires, right? It has resistances, right? It has electrical equipments like bulb, lamps between terminals of a battery. So guys, all these electric components makes the electric circuit. We have ammeter, we have cell, we have resistor, we could also have a key, right? We have many elements, we have a bulb. All these elements combine together to give a electric circuit. So it is continuous path. You can see there is nowhere where the circuit is broken. It's a cell, obviously it's not broken by the way. So we have a continuous path. It is not broken at any point. Obviously if you cut the wire at any point, will the circuit with the current flow? Obviously not. You have broken the path. So it's continuous path, right? So we have ammeter in series, we have wire, we have cell, we have resistor, and we have voltmeter connected in parallel with the resistor. Voltmeter is used to measure voltage. What is the voltage across this resistor? 10 volt, 12 volt. And we have a ammeter also, like we are measuring the current, like it can measure the current like 2 ampere, 10 ampere, and so on. So this is the electric circuit that you have to draw in your notebooks. Okay, it is the continuous path consisting of all these elements. Fine. Now keeping all these things in mind, we have a Ohm's law. What is Ohm's law, guys? Let's have a brief discussion on this. Suppose, guys, I have taken a bulb, right, and I have a key closed, I have a battery, right? Okay, fine. Now this is bulb, and let's say the voltage across the battery is 2 volt, right? And let's say we also have a ammeter here, we also have a ammeter here, let's say, which can measure the current. Okay, so guys, let's say the current in the circuit is I is the current, let's say, or you can take any value. Let's say the current is 2 ampere. You can take any value if you want. I'm just taking an example. Let's say the current is 2 ampere for voltage of 2 volt. Now guys, if I increase this voltage, if I draw the graph of current versus voltage. If the voltage is 2 volt, the current is 2 ampere, right? Let's say if I increase this voltage to 3 volt, the current will become 3 ampere. The current will increase, na guys, if you change the battery, the current will be more. If you increase the battery, the potential of battery, we have more current, right? The more the charge, the more the current. Similarly, if I keep the voltage to 4 volt, the current will be 4 ampere. If this is 5 volt, the current would be how much? Can you guess it now, guys? If this is 5 volt, this is 5 ampere. So guys, what can you guess from this? What can you guess from this? That both are increasing at the same pace, isn't it? By the same amount. So this was first stated by Sir Ohm. He told us that the current flowing across any conductor, the amount of current flowing across any conductor is directly proportional. Directly proportional means both are, if you increase one, the other will increase. If one increases, other will increase. This is the meaning of directly proportional. Other increases. And what is inversely? If you increase one, the other has to decrease. So directly proportional means if you increase the voltage, the current will increase, right, across the conductor, while temperature remains constant. I will tell you why it is written here, but for the timing, just keep this in mind. Temperature has to remain constant. like we are conducting any experiment at room temperature 25 degrees centigrade. So guys, current flowing through a conductor is directly proportional to voltage. If I remove this proportionality constant, I will get I equals to V by R, where R is a constant known as resistance of the circuit, known as resistance of this circuit. So guys, both are linearly related. That is, we have a linear relationship between current and voltage. Can you see it? We have a linear relationship between current and voltage. If you increase current, the voltage will increase. And the slope. Now what is the slope? Guys, what is the slope of any graph? Let's say this angle is theta. Slope would be tan theta. Tan theta will be what? Perpendicular upon base. Perpendicular is voltage, base is current. V by R I is nothing but R. From this equation, V by I is keep this thing in denominator and you will get resistance. So slope of VI graph gives you resistance. So this was stated by Ohms, that I is nothing but proportional to V. If you increase the voltage, the current has to increase and vice versa. Clear? So this was the Ohm's law. This is very, very famous equation. V is equals to I into R. And this is for metallic conductors, right? And the conductors which follow the Ohm's law known as ohmic conductor. Ohmic conductors which follow Ohm's law. Clear guys? So this is Ohm's law, you should be knowing. So if you increase the voltage, the current has to increase. So I is proportional to V. Now let's talk about the constant, this R. We have a constant here guys. Can you see it? We have a constant here known as R and this is called resistance. Let's talk about this resistance now. What is resistance? See, let me brief you this, then we will look up into the definition. So suppose there is certain amount of current in a wire, that means there is a flow of electrons, right? So guys, electrons are flowing from left to right, the current will flow from right to left by convention. Okay, it's a convention basically. The direction of flow of current is opposite to the direction of flow of charge. So guys, a wire is having many electrons, like it is of the order of 10 raised to the power 28 per centimeter cube. Per centimeter cube we can have this much of electrons. So guys, don't you think so? When there is so many electrons are flowing through a small wire, don't you think so they will collide with each other? They will collide with each other. They will collide with the positive ions here. Don't you think so? Suppose this electron, this positive ion will attract or oppose this electron. It will oppose it. It will hold it back, this positive ion. So basically the thing is ki the motion of the electrons is opposed. Don't you think so? Don't you think so? The motion of the electrons is opposed. Why? Because of each other. Because we have so many positive ions, we have so many electrons. So motion of electrons is opposed guys. So this opposition is what is meant by the resistance. So it is the property of a conductor by virtue of which it opposes the flow of electric current. Every conductor has some resistance. It's not like resistance cannot be zero practically. Every conductor has some resistance. So you can also get this from the diagram. The voltage is trying to push. You can see the voltage is trying to push the current ampere. The blue one is the current, green one is the voltage. But you can see the red one standing upwards. It's resistance. It is basically stopping the current. So this is Ohm's law. V is trying to push current, but R is stopping that. Can you see it? So this is resistance. It's a very good picture to understand it, right? So this is resistance. It is stopping the current, right? It is opposing. So what is the unit of resistance? It is ohm, right? The ohm is denoted by a Greek letter omega, right? And resistance is a scalar quantity. It is not vector. It does not have any direction. Only magnitude is there. Clear? So this is the resistance, the oppose. Now question is, son, on what factors does the resistance depends? Are there any factors on which resistance of a conductor depends? Yes guys. Basically resistance depends on the length, it depends on the area of cross section or the area of the conductor, or you can also call it thickness, nature of the material, and the temperature. Now let's have a look on how. Guys, suppose if I take two conductors, one is this of same cross section, one is this. Let's say we have electrons flowing from here to here. Okay, so guys, what do you think? Let's talk about this electron. Which electron will get more opposition? Obviously this electron. It has to travel a longer length, right? It has to travel here, it has to travel shorter, so resistance is proportional to length. More length means more opposition and more resistance. Okay, so R is proportional to L. What about the area, guys? If I talk two conductors, so what do you think? In which case it is easier for the electron to cross? Obviously in this case it has more space. So more area means lesser resistance. So it is inversely proportional to the area, right? So guys, if I combine these two equations, R is proportional to L upon A, proportionally constant if you removed, you will get a new constant known as rho. And this rho is known as the resistivity. Okay guys, this rho is known as the resistivity. Resistivity, I will tell you this, what is resistivity. So it depends on the nature of the material. The resistivity, it depends on the nature. Like for copper we have different resistivity, for aluminium we have different resistivity, for silver we have different. So it depends on the type of material. Next is temperature. Now guys, let's say if I heat up this conductor, what will happen? What will happen? The rate of collision will increase. Don't you think so? They will start to vibrate with more energy now. That means the collision will increase. More collision means lesser resistance, more resistance. So for a conductor, if you increase the temperature, the resistance will increase. For a metallic conductor, if you increase the temperature, the resistance will increase because we have more collision. So R is rho L by A. Clear? Fine guys, now let's have a look on this resistivity. Basically guys, resistivity is a fundamental property. Why fundamental? Because it depends on the nature of material, the fundamental nature, right? If I go to the atomic level, it depends on the nature of the material. It is not dependent on the external parameters like length and area, right? That measures resistivity of a material, that measures how strongly it resists the current. See guys, more resistivity means more resistance. So resistance is the property by which it will oppose the motion, right? But what is resistivity? It measures how strongly it will oppose the current, how strongly it will oppose, that is resistivity. But this property is known as resistance, right? So resistivity, you can measure resistance by using resistivity. You measure it basically. So resistivity is equals to resistance of a conductor of length 1 meter and area 1 meter square. R is nothing but rho L upon A guys. If length is 1 meter, area is 1 meter square. Don't you think so resistance will be equals to resistivity? This is what is written here. Resistivity of a conductor is resistance for unit area and unit cross section. What is the unit for resistivity? From here guys, what is resistivity? It is nothing but R into A upon L. Area in meter square, it is in meter. So unit of resistivity is ohm meter. Okay, the unit of resistivity is ohm meter. Clear? Okay. So we have a resistivity of different conductors. Like you can say for conductor, the value of resistivity is very less. That's why they are good conductors, right? For silver, it is the least resistivity is for silver. Like we have increasing as we go downwards. Then we have alloys. The resistivity of alloys is little bit more than that of conductors, like constant and manganese. You don't have to memorize this. This is just for your exam, just to observe or just to examine, right? Nichrome, manganese. But for insulator guys, you can see the value has gone too high. That's why they are insulators. They won't conduct anything. They won't conduct anything. Clear guys? So we have alloys, we have insulators, and we have conductors, right? We have conductors, alloys and insulators. So let's have a look on this question. It is written the diameter of a wire is reduced to 1/5 of its original value. Diameter is reduced to 1/5 of its original value. If initial resistance is R, what will be its resistance after reduction? Okay, see guys, diameter of a wire is reduced to 1/5. Okay, so let's take initial condition. This is initial, this is final. So let's say resistance is R, new resistance is R dash. Okay guys, okay. Let's say length is L, here length is L dash, area is A, here area is A dash. What is area guys? It is pi r square. And what is area here? It is pi r dash square. Now diameter has been reduced to half. So if here diameter is D, here diameter D dash will be D by 2. So guys, if I relate the area, so what is R dash? If diameter is half, resistance would also be half. So R dash will be R by 2, isn't it? Resistance is half means diameter is half, right guys? So basically it will be pi r square upon 4. So the area has been reduced to what? 1/4. If you halve the radius or halve the diameter, the area will be reduced to 1/4. Now guys, the volume of the wire will remain constant. Don't you think so? Volume is area into length, right? So L upon L dash will be equal to A dash upon A. A dash is A by 4, right? A dash is A by 4. Okay, are you getting it? Yes, so it would be 1 by 4. So guys, L upon L dash is 1 upon 4. Okay, L upon, it's 1/5, my bad. It's 1/5, not reduced to 1/4, it's 1/5. It should be how much? 25. If radius is, diameter is reduced to 1/5, the radius will also reduce to 1/5. It would be A by 25. It's A upon 25, 25, 25. Okay, diameter is reduced to 1/5. Clear guys? Okay, so this is the ratio of length and this is the relation between area. Can I find the resistance now? Can I find the resistance now guys? R is what? Rho L upon A. R dash would be what? Rho L dash upon A dash. So guys, R upon R dash would be how much? L upon A divided by L dash upon A dash. So it will be L upon A into A dash upon L dash. What is L upon L dash? Oh wait, what was L upon L dash? 1 by 25. Right, what is A dash upon A? It is also 1 by 25. So it is 1 upon 625. Clear? So guys, you can see the R dash is nothing but how much? The length has been what? Diameter has been reduced, the length has been increased. So R upon R dash is 1 upon 625. That means R dash will be 625 R. That's it. Clear? Okay, which option? D option is correct. So this is how you should approach towards such questions. R is rho L by A. Next is you have to find the current. You have I versus V graph is given. So guys, you have to find the current when potential difference is 2.5 volt. You have to find the current. So guys, can I find the resistance? For that, what is the slope of this graph guys? I had told you the slope. What is the slope? It is delta I upon delta V. It is tan theta na? Tan theta. If I take any triangle, this is theta. So this is delta I, change in current upon change in voltage. So guys, I by V is nothing but 1 by R. So 1 by R is delta I upon delta V. What is delta I in this triangle? 0.3 minus 0.2. 0.1. What is delta V? 2 to 3. 2 to 3. So 3 minus 2. So it will be how much guys? 1 upon 10. So how much is the resistance? It is 10 ohm. Now you have to calculate the current when potential difference is 2.55 volt. So guys, by Ohm's law, I is what? V by R, 2.5 upon 10. So it will be 0.25 ampere. Finish. Okay. Just calculate the slope, nothing else. I is V by R. V is 2.5 upon resistance, and you will get your answer. Are you getting it? Okay. So I is V by R. V is 2.5. R is 10 ohm. Right? 0.3 upon 0.3 minus 0.2. 0.1 upon 3 minus 2. So it will be 0.1 by 1, which is 1 by 10. So R is 10 ohm. Okay. Next question. Sorry, concept. So now we can combine the resistance is denoted by this, and we can combine the resistance in two combination. One is series and one is parallel. So guys, if I combine the resistance in series means resistance are connected end to end. So guys, don't you think so? If I is the current flowing through R1, same will flow through R2, and the same will flow through R3. So in series combination, the current is same. It's like it's like the coaches of the train, back to back. The resistance are connected back to back, one behind the another. So the same amount of current will flow through all of this. So this is called series combination, only connected at one end. You can see these two resistances are connected at this end. These two are connected at this end. Only one end is connected. They are holding only one hand, right? So what about if it hold two hands? I will tell you. So this is the key. This is the battery. So what is in series combination or more of two or more resistances joined end to end, so that same current flows through them. Same current, guys. The voltage will be different. Current is same. V is different. Current is same. V is different. Okay. So guys, if I ask you, if I want to replace these resistances by a single resistance, what will happen? If I want to replace all these resistances by a single resistance, what will I do? Just add up the resistances. So guys, R is nothing but R1 plus R2 plus R3. From where did you have you got this? See guys, let's say voltage here is V1, here V2, here voltage is V3. Okay, so guys, what is total voltage? Is V1 plus V2 plus V3. V is I into R. It is I1 into I into R1. Right? It is I into R1. Right? It is I into R2. It is I into R3. So guys, if you take I as common, it would be R1 plus R2 plus R3. I is cancelled. So R would be R1 plus R2 plus R3. Series combination. What are the properties of series combination? The current is same in all. Okay. Next is total resistance is the sum of all the resistances. R is R1 plus R2 plus R3. Now what is total voltage? It is also equal to sum of voltage across all the combinations. V is V1 plus V2 plus V3. Clear? Okay, next is net resistance is greater than any of the individual resistances. That is, what was net resistance, guys? R1 plus R2 plus R3. So R is greater than R1. R is also greater than R2. R is also greater than R3. Can you see it? Can you see it? So that means we have a maximum resistance in series. We have a maximum resistance in series combination. We have a maximum resistance in series combination. Now let's try a question on this. Let's try a question. What is written here? Oh, it is written that a resistance of 6 ohm is connected in series with another resistance of 4 ohm. A 6 ohm resistance is connected in series with a 4 ohm resistance, and a voltage of 40 volt is applied across the combination. Right guys, you have to find the current. So guys, first we have to calculate total resistance, which is R1 plus R2 plus R3. right? Are you getting it? We don't have R3, my bad. Okay, so what is R1 plus R2? 6 plus 4, it is 10 ohm. Getting it? Okay, so what is current? It is V by R. V is how much, guys? 40 upon 10. So current would be 4 ampere. And potential difference across 6 ohm. Guys, what is potential difference across 6 ohm? 6 ohm. Current through it into 6 IR. What is current through 6 and 4 ohm? It is 4 ampere. So voltage would be 4 into 6, which is 24 volt. Out of 40 volt, we have 24 volt across 6 ohm, and rest 16 volt would be across 4 ohm. Clear? So this is how we approach. Just use Ohm's law and use a combination of series. Okay, guys, clear? Now what about the another combination? I had told you, what if two people hold both of their hands? So this is what happens here. All the resistances are holding both of their ends. You can see one end of all the resistances is connected here, another end of all the resistance is connected here. Current is I1, I2, it is I3. From middle one we have I3, right, guys? So guys, don't you think so the current I is divided in 3 parts? So can I say that I is nothing but I1 plus I2 plus I3? The same current is divided into 3 parts, na? And voltage across all 3 combination is same. Keep this thing in mind. Voltage across all is same, guys. Voltage across all is same. So I is nothing but V by R, where R is effective resistance. I1 is V by R1. Let's say voltage across all is V. By Ohm's law, I2 is V by R2. It is V by R3. So if I take V common, it is 1 by R1 plus 1 by R2 plus 1 by R3. Clear? So if there is something is cancelled, obviously, so from here 1 by R is 1 by R1 plus 1 by R2 plus 1 by R3. Okay, guys, this is for the series parallel combination. Now what are the various properties we have in parallel combination? First is the sum of reciprocal of all the resistances give you the is equals to sum of reciprocal of individual resistances. 1 by R is 1 by R1 plus 1 by R2. Next is current is inversely proportional to the resistances. You can see, guys, can you see from here that I is V by R. What is I1? I1 is V by R1. What is I2? It is V by R2. What is I3? It is V by R3. So you can see current through each resistance is, and resistance, the value of that resistance is inversely proportional. More resistance means we have a lesser current through that resistance or through that branch. This is what is written here. Higher resistance means lower value of current, and total current is equals to sum, that is I equals to I1 plus I2 and I3. Now voltage across each resistance is same in parallel and is equals to voltage of the whole group, that is voltage of cell. The voltage across each resistance is equal to the voltage of the cell. Is equals to the voltage of the cell. Okay, is equals to the voltage of the cell. Write it down, guys, in the meantime. Clear? So in parallel combination we have a we have this thing. Keep this thing in mind, guys. Now question arises. See, basic 2018. It has been said that we have 3 resistances. How would you join 3 resistors each of 9 ohm to get equivalent resistance of 13.5? Guys, you have been given 3 resistors each of 9 ohm. How would you connect them to get effective of 13.5? Think about it. Think about it. Can I use a combination like this, like 2 9 ohm in parallel and 1 in series with them? Will this work? Will this work? 9 on 9. The effective of this will be 4.5, isn't it? what is the effective value of this resistance, guys? This is 9. What is the effective value of this resistance? 9 or 9 parallel. So 1 by R would be 1 by 9 plus 1 by 9. It will be 2 by 9. So R would be 9 by 2, which is 4.5 ohm. So this resistance would be 4.5 ohm and this is 9 ohm. So now these two are in series, right? Now these two are in series. What will happen now? The two resistances are in series. So what is net? It is 9 plus 4.5, which is 13.5 ohm. Okay, the two resistances are in series. 9 plus 4.5. Clear? Now how would you get 6 ohm out of these? How would you get 6 ohm out of these? Can you tell me? 6 ohm out of these. Think about it. How can we get that 6 ohm out of these? Okay. Can we connect it like this? 9 ohm, 9 ohm, and in series we have 9 ohm. Will it work? Think about it. Will it work? 9 into 9, 9 and 9 series. This would provide us with effective of 18 ohm, right? And then we have 9 ohm in parallel. So what is effective now? Can you tell me? 9 and 18 in parallel. So 1 by R is 1 by 9 plus 1 by 18. This would be how much, guys? 18. 2 plus 1. 3 upon 18, which is 1 by 6, which is 1 by R. So guys, what is effective? 6 ohm. So if you connect them in this combination, you will get 6 ohm. And if in this combination, you will get 13.5 ohm. Clear? So this is how you approach towards such questions. Okay. Another good question. Find out the current flows through 10 ohm resistor. What is the amount of current flowing through 10 ohm resistor? Guys, you don't have to find the effective resistance here. Why? See, what is the voltage across 10 ohm resistor? Isn't it 6 volt? Guys, the resistance are connected in parallel. I had told you in parallel combination, the net voltage, across all the elements is same. The voltage across battery is same as the voltage across all the elements. Clear? So if I ask you to find the current through this, what is current I through this? By Ohm's law, current would be voltage upon resistance. Isn't it 0.6 ampere? Direct question B. 0.6 ampere. Just use the concept that voltage is same in parallel combination. Okay. Now next is heating effect of electric current. Guys, whenever we heat, see, basically, you know, whenever there is a flow of current across any circuit, the circuit gets, the temperature of the circuit increases. It start to heaten up. Why is it so? Because there is a collision, the electrons will collide, the temperature will increase, right? So it's a effect of current. So in certain cases we use the heating effect, like in bulb we are using heating effect. In iron also, in electric kettle, in geyser, we are using heating effect here. The current is flowing through an alloy, through a nichrome alloy, right? Why alloy? Because it has higher resistivity. Higher resistivity means more current and more heat will be there. I will tell you. So it is, these are the applications of heating effect of electric current, right? Whenever there is a flow of current, there will be certain amount of heat that will be produced, and that heat is useful in certain ways and it is not useful in certain ways. For example, if you're working on a laptop, it starts to heaten up. That is heating effect and that is not useful at all. But if this is heated, this is heated, this is heated, we are using the heat na. So it has both its advantages and disadvantages. So guys, in 1841, basically Joule was a physicist who told us that the amount of heat produced in a wire is directly proportional to square of current. The amount of heat is proportional to the square of current, right? And directly proportional to the resistance, and also directly proportional to the time for which it flows. right guys? So if I combine these equations, H is equals to I square R into T. H is equals to I square RT. This is heating. H is heat, or I can say the amount of heat produced. The amount of heat produced. H is equals to I square RT. Clear guys? H is equals to I square RT. So proportional to time, proportional to resistance, proportional to square of current. If you increase the current, if you double the current, the heat will become 4 times, not double. If you double the resistance, heat will be doubled. If you increase the time by double, the heat will also double. So it is proportional to square, or it is directly related. So guys, as I had told you, in some cases heating is required, while in many cases such as electric motor, generators, transformers, it is highly undesirable because it's a loss of energy. But we have certain appliances like incandescent lamps, toasters, electric irons, stoves, right? In this cases heat is used. So here electric energy is converted into both heat and light. Electric bulb, heater, electric energy is converted into both heat and light energy. So here it is useful, here it is not useful. So it's a disadvantage, right? And this is advantage. This is advantage of heating effect. This is disadvantage, and this is the this is disadvantage, and this is the advantage of heating effect of electric current. Whenever there is a flow of certain amount of current, right, through any circuit, obviously it will heaten up. Now let's do a numerical on this, guys. Let's do a numerical. Just pause the video and calculate this. Just pause the video, calculate this. We have a resistance of 20 ohms, current is 5 ampere, and find the heat develop in 30 seconds, right guys? So what is H? H is nothing but I square RT. Yes, H is nothing but I square RT. So I square, that is 5 square into resistance 20 into time is 30. So 25 into 600. This would be how much, guys? 15000 joules. Clear? This is it. 25 into 20 into 30, 600, 25 into 600, it is 1500 joules. This is the amount of heat produced. Clear? Very simple questions. Very simple questions, guys. H is equals to I square into R into T. Now what is electrical energy, guys? See, I have told you conductors offer some resistance to the flow of current, right? For example, if there is a resistance in a circuit and the battery is applied, the current or some charge will flow. Guys, don't you think so? The battery has to spend some energy in doing this work. It has to do the work to make this charge flow. So that means the energy is spent by the battery. Here energy is spent by the battery. So that energy is electrical energy, or the amount of energy. What is the energy? The energy spent by the battery is nothing but the work done, right? So where will that energy go? It will dissipate it in the form of heat in this circuit, which is known as electrical energy. So work must be continuously done to maintain the flow of current by the battery. So basically what does resistance do? Resistance dissipates all that energy in the form of heat. That's why here work is nothing but equal to heat. All work done by the battery, all the electrical energy spent by the battery will go in the form of heat in the resistance. So this is electrical energy. This is nothing but I square RT in the form of heat. Clear? So electrical energy is I square R into T. Are you writing it, guys? Are you writing it down also? Just keep on writing, guys. Electrical energy spent is nothing but I square R into T. Now we have some bigger units of energy also. Commercial units of energy. We have some commercial unit of energy. Commercial means for commercial purposes, like when we get the electricity bill of our house. You all must have seen that. So we have it calculates the amount of energy spent. You must have heard the amount of unit you have burned in a month. That unit is nothing but energy, and that unit of energy is nothing but kilowatt hour, right? Kilowatt hour. So guys, the SI unit of electrical energy is joule. For commercial purposes we use bigger unit called kilowatt hour, right? So guys, see, basically what happens is, what I have told you that work done by the battery is nothing but energy, right? Energy spent, or I must say electrical energy. Work done by the battery is nothing but energy. What is work? Work is nothing but power into time, right? So guys, from here what can you infer? You can infer that energy is nothing but power into time. What is power? If I take power in kilowatt and time in hour, don't you think so the unit of energy is kilowatt hour, right? So if power is the energy, unit of energy is kilowatt hour. So guys, if power is 1 kilowatt and time is 1 hour, so don't you think so from this formula the energy spent will be 1 kilowatt hour? Don't you think so? The energy spent will be 1 kilowatt hour. Energy is power into time. Power is 1 kilowatt, time is 1 hour. So energy will be 1 kilowatt hour. So if you spend 1 kilowatt of power in how much time? In 1 hour, the energy spent by you would be 1 kilowatt hour. And this 1 kilowatt hour, guys, is nothing but the unit. You say it is 1 unit. You say na, you have spent 300 units in a month, 400 units in a month. That means the amount of energy in kilowatt hour. Clear? So bigger unit. So 1 kilowatt hour is the amount of electrical energy consumed when electrical device of power 1 kilowatt, and it is used for 1 hour. 1 kilowatt for 1 hour. Now what is the relation between kilowatt hour and joule? Both are unit of energy, but kilowatt hour is the bigger unit of energy, right? So 1 kilowatt hour. See, basically if I ask you what is 1 kilowatt hour, it is 1 kilowatt into 1 hour. 1 kilowatt is 1000 watt. 1 hour is how many seconds? 60 into 60. So it will be 3.6 into 10 raised to the power 6 joules. So 1 kilowatt hour is equivalent to this many joules. Clear? So 1 kilowatt is equals to this many joules. 1 kilowatt hour is equals to 3.6 into 10 raised to the power 6 joules. Is it clear, guys? Okay. So let's calculate this question. The answer for this. Refrigerator. What is the power of refrigerator, guys? The power of refrigerator is 400 watt. It is used for 8 hours per day. So time is 8 hour, right? What is the power in kilowatt hour? 400 upon 1000. So it is 0.4 kilowatt. Not hour, it's kilowatt, right? So what you have to calculate? You have to calculate the cost of energy to operate it at for 30 days. So guys, energy spent in 1 day. Energy spent in 1 day. How much is the energy spent in 1 day? It is 0.4. Energy uses power into time, 8. So it is 3.2 kilowatt hour, right? So what is the energy spent in 30 days? Energy spent in 30 days in single days is 3.2. For 30 days it is into 30. So it is 96 kilowatt hour, right? For 30 days. What is the cost of 1 kilowatt hour? 2 rupees. So how much is the cost, guys, of electrical energy? 96 into 2. So it is 192 rupees. 192 rupees. So this is the cost for it. You have to calculate energy spent in 1 hour, 1 day, which is 8 hour. Then you have to calculate energy spent for in 30 days. Multiply it by 30. Then multiply it by 2, the cost per unit per kilowatt hour. So this is the amount of bill you will be getting. Clear? Okay. Now guys, we have another values for power. Let me tell you that. See what we had seen. we had seen that power is nothing but work upon time or electrical energy upon time. What is work? It is charge into potential difference. I have told you, right? Q by T. Q by T is nothing but current. Sorry, Q by T is nothing but current. So the power is I into V. What is V? It is IR by Ohm's law. So power is I square by R. Or from here you can also calculate I is what? Put value of I as V by R by Ohm's law. So power is also V square by R. So just put the value of I, you will get this formula. Just put the value of V, you will get this formula. So what is the, and this is the basic formula. So what is the formula for power? V into I is equals to V square by R is equals to I square R. Guys, this is the formula for power, to calculate the power. Which formula to use? It depends on the question you are solving. Which formula to use? It depends on the question you are solving. Clear? So the rate at which energy is dissipated or consumed is known as electric power, guys. The rate at which energy is consumed. Rate means work upon time, right? The rate at which energy is consumed, that is work upon time. It is electrical power. So power is given by, as I have told you, power is work upon time, which is I square into R. Power is nothing but I square into R. The unit of electric power is watt. The power is measured in watt, which is joule per second. What are the bigger units? It is kilowatt hour. The bigger units could be kilowatt hour. 1 kilowatt hour is equals to 1000 watt. 1 kilowatt hour is equals to 1000 watt. Wait a minute. 1 kilowatt hour is equals to 1000 watt. Guys, another unit we have is known as horsepower. What is the history for this? See, in the era of steam engines and all, we used to measure power of any body by comparing it with the power of horses. We used to compare power with horses, like of engine, of steam engine, right, of any wheel, any invention. So from that time, the energy of the unit of power also came out to be in horsepower. Basically, it is the we calculate the power of any body in terms in if we compare the power of that body with the power of a horse, right? So it's a history basically. So if I ask you, so 1 horsepower is nothing but 746 watt. 1 horsepower is nothing but 746 watt. Clear, guys? So this is the unit for power. 1 horsepower is 746 watt. Just keep on writing this. So what are the for these formulas? I have told you. Now question is, an electric bulb is connected to 220 volt generator. The current is itna. What is the power? Guys, what is power? Power is V into I. What is voltage? It is 220 volt. I had told you, depending on the question, you use the formula. I is also given, it is 0.5. So this is calculated, it is 110 watt. Which option is correct? Option B is correct. Just simple. Depending on the question, you just choose the formula and you will get your answer. Okay. Next question. Very, very important question, guys. It has been said two bulbs are connected in parallel to electric main supply like this. Two bulbs are connected to main supply like this, right? Find the current drawn by two bulb if supply voltage is 220 volt. We have a 100 watt bulb and voltage is 220 volt. This is a 60 watt bulb and voltage is 220 volt. You have to find the current drawn. So guys, can I calculate the current here? I1 for this bulb. I1 is what? I1 is P upon V. How much is the power? 100. It has been put with the 220 volt battery, right? So voltage is 220 volt. Power is how much? 100 watt. Voltage is 220 volt. So it will 2, 5, 2, 11. So it will draw a current of 5 upon 11 ampere. Let's say the current through this bulb is I2. So guys, what would be I2? It is power 60 upon voltage 220. So 3 upon 11. So 3 upon 11 ampere. Just very, very simple. You know the power, you know the voltage it has been supplied with. Just calculate P equals to VI. From P equals to VI, the current drawn by the bulbs. Right? You could also find the resistance of both the bulbs, then find effective resistance, then calculate current. You need not to do that. You know the power, you know the voltage across this bulb. Just simple apply P equals to VI and you will get your answer. Right? So guys, what is the current they drawn? Total current would be I1 plus I2. They are connected in parallel now. So it will be 5 upon 11 plus 3 upon 11. So total current drawn is 8 upon 11 from the 220 volt source. Clear? This is the total current drawn. So find the current drawn by the bulbs from the line. So just calculate individual current and you will get your answer. Okay, fine. Are you getting it? Now electric fuse, guys. What is electric fuse? See, basically most of the time what happens is we are supplied with more amount, like if the current suddenly becomes too high, our appliance can get damaged, obviously, because every appliance has a current limit. If an appliance is a current limit of 10 ampere, but if you supply it 12 ampere, it will be damaged. If you supply it 15 ampere, it will be damaged. So to avoid this damage, we use an element known as fuse. It kind of looks like this, and it is made of alloy of high resistivity. So it's a fuse wire. It is made up of what? Let me tell you. Fuse, an electrically fusible wire of short length put into circuit for it's a safety element, I must say. It is arranged to melt blow at a fixed current. The amount of current why it will melt, because if current is flowing through this fuse wire, it will heat up, then it will melt up and the circuit will be broken. So it is made up of alloy of lead and tin, 37% lead and 63% tin. It's a alloy having more resistivity, so it will be burned up at, the more heat will be produced and it will be burned up. So we need a bit of high resistivity here. So it's a high resistivity and low melting point. Resistivity high means we need more heat, but it has low melting point, can be melted at a very smaller low temperature. So as the safe limit increases, the fuse blows and current is stopped. That means every appliance has a safe limit, like 2 ampere is a safe limit for any appliance, let's say. So if current becomes greater than 2 ampere, the fuse wire will melt and the circuit will be broken, and as a result your appliance will be prevented from getting damaged. So this is the role of fuse wire. It is made up of alloy. Clear? Now what are the domestic heating appliances? Like I had told you, we have iron, heater, radiator. Works on the fact that when current is passed through a wire, the wire is heated and it will radiate some energy. The most widely used material for making heater wire is nichrome. Why do we use nichrome, guys? Because it is a alloy of nickel and chromium, right? So why is it chosen? Because it has high resistivity. High resistivity means more heat will be produced. It has very high melting point. It can withstand high temperature without getting oxidized. Oxidized means if a metal wire, if the alloy is oxidized, it comes in contact with air, it will undergo a chemical reaction and will be damaged, kind of. Its property will get changed. So we don't want it to get oxidized at such high temperature. Also melting point is high. It won't melt easily, right? Like we have in fuse. Clear, guys? Nickel and aluminum in the ratio of 4:1. So that's why we use nichrome alloy in heating wires, in heater, as a coil in heaters. Okay, clear? This is very, very important. You will get questions from this surely. Now we have earthing. Earthing means to connect. See, what happens is basically, if suppose any metal appliance is working, we have a wire, we have a live wire for the current. If the current wire comes in contact with the metal body of the conductor of the appliance by mistake, let's say by any means, and if you touch that conductor, you will get electric shock. So to prevent that, we keep the earthing of certain appliances. Earthing means, what do we do? See, we connect a wire through that metal case to the earth, because earth is having zero potential. It can consume as much current as you want. So earthing means to connect the metal case of electrical appliance to earth by means of metal wire, which is known as the earth wire. So in household circuit, we have three wires. We have a live wire, we have a neutral wire, we have a earthing wire. Live wire means in which current is there, it has certain potential. Neutral means no current will be there. One of the earth wire is buried into earth, right? So basically you must have seen three plug pin. So this is for live wire, this is for neutral wire, this is for earthing, the bigger one, right? So metal casing of appliance will now always remains as zero potential. That means as you can give as much current as you want, all current will flow to the earth. We say the appliance has been earthed or grounded. Clear guys? By this means, if by chance live wire touches the metal case of iron, electric iron which has been earthed, all the current will pass from that wire to the earth, and therefore we won't get an electric shock. Clear? So this is the purpose of earthing. Now we have galvanometer guys. Galvanometer is an instrument that detects the presence of current, right? It detects the presence of current. It gives the deflection when certain amount of current is flowing through it. The pointer is 0 whenever there is no current, right? And it can deflect either to left or to the right depending on the direction of current. For example, if it is deflecting to right, then for left deflection it will deflect to the left for right deflection, depending, right? It can deflect either to left or right of the 0 mark depending on the direction of current. So it detects the current, it does not measure. If you want it to measure the current, we use ammeter guys. Ammeter kind of looks like this. Microampere is the unit. So it measures the strength of current in ampere in a circuit in series. So we connect the ammeter in series, right? So for any appliance we use resistor, and we can connect ammeter in series to the circuit to measure current it is flowing through, right? So the resistance of ideal ammeter is 0 guys. We don't want it to have a certain amount of resistance. So the resistance of ideal ammeter is considered to be 0. It should be minimum. Okay. Then we have voltmeter to measure the potential difference or to measure the voltage. It has very high resistance, right? Voltmeter is having a very high value of resistance, and resistance of ideal voltmeter is infinite, very high resistance ideal voltmeter, and it is always connected in parallel with the circuit. For example, if I want to measure the voltage across this resistor, we measure it like this. Like guys, so we connect voltmeter like this, like we have a circuit here. So we have ammeter, we have galvanometer, and we have voltmeter. Clear guys?